All yours. Hi, Veronica. How are you?
Good, thank you.
Wow, it's nearly over. Tough day today, huh? Day 3 at the fair. So how do you do?
Very good. It's very busy and it's really good to see everyone again. So
Okay,
really
great. So you're a business development drive-train digitalization responsible within Siemens Digital Industries. And I guess you had lots of customer talks at the fair booth. I imagine you had great discussions, great information coming along.
Yeah, digitalization, especially simulation, what we will talk about now, is really a major topic. So I'm really great with the outcome.
Okay, so what are the typical questions that machine builders might have in the design and engineering phase? What you get?
So firstly, actually, I would like to know, are there any OEMs or system integrators here in the audience? Okay.
All right, okay. Well, this is what we expected. All curious now to learn a bit more.
Yeah, so this will be very interesting for you, right? So typically you develop a machine, and at the end of the development process, you test the behavior of the drive and of the machine. And then you find out that there are some issues and that you need to make some changes, basically. So you need to put in more effort and more time to make these changes, and that drives up the cost. So one major question for OEMs is, how can they make this development process more efficient, and how can they speed up their time to market? Is there perhaps a way to identify issues earlier and reduce the testing efforts? And also, how can they reduce the risk of operational faults and of the cost? So these are some of the major questions that keep OEMs up at night, basically.
Okay, so most applications involve drive systems. What are the major challenges when it comes to drives and motors?
Yeah, so firstly, you definitely want to make sure that you have selected the appropriate drive system for your application. So you want to make sure that it meets the requirements according to the load, but also you don't want to over-dimension it, because that drives up the cost, right? Secondly, you want to be able to verify the communication between the drive and the PLC, your automation system, so that you can test the behavior of the drive depending on the instructions that the PLC is giving. And thirdly, you really want to make sure that the machine overall behaves exactly as you've planned it. And one major tool to address this is simulation. And you can add the digital twin of the drive to your existing machine simulation. And by that, you can speed up the engineering phase, speed up the time to market, and also improve the quality of the machine and the robustness.
So what is a digital twin of a machine in your case, and can you describe why it's such a good idea to work with it?
Yeah, so perhaps let's look at the real machine first. So the machine you see behind me is testing if the bottles are sealed properly. So there's a conveyor belt, and the bottles are located on this conveyor belt. And then you have a vacuum device which is moving up and down to see that to test that there's no leakage. And in this design stage, you might have a few questions. So you might wonder, how can I increase the throughput of the machine? How fast can the conveyor belt move so that the bottles don't fall over? How can I synchronize this vertical lifting of the vacuum device with the conveyor belt? And also, how powerful do my drives need to be? So you can to answer these questions, you can look at the components of the machine. So that is the automation system, so your PLC, but also your drive system and the mechanical system. So in this case, the conveyor belt and the vacuum device. And of course, you can wait for a prototype to test all these things, or you can create a digital twin of the drive and start much sooner. In the digital twin of this machine, you actually have exactly the same components that are represented in a virtual model. So you have the automation model, the drive system model, and the mechanical model. And all of these can interact in a tool, for example, like Siemens. And there they can help you to test various configurations, and you can identify the issues. If you want, you can simulate the entire machine. But if you're interested in, let's say, if you're only interested in the drive system behavior, you can only implement the digital twin of the drive system. So it's really important to understand that there's not one digital twin. Rather, the level of detail depends on the questions that you're asking, that you're trying to tackle. So the digital twin might look different for this machine depending on the questions that you're tackling.
But can you tell us a bit more about how you create the digital twin of the drive?
Yeah, sure. So to make this creating this digital twin very easy, we've launched our first simulation offering called Dynamics Drive Sim Basic about a year ago. And Dynamics Drive Sim Basic is basically a generic model of the drive, which focuses on the Profi drive and the speed controller. And to guarantee that in the real world, the drive behaves exactly as you've planned it in the virtual world, these functionalities are validated against the real Dynamics runtime. Drive Sim Basic comes in the form of a so-called functional mockup unit, FMU, which is an industry standard. It's an interface, and that allows you to import this function block into a time-based simulation tool. So, for example, Simit, SimCenter ArmaSim, or also MATLAB Simulink, so also third-party simulation tools. From there, you can then connect it with other tools from the simulation landscape. So, for example, PLC Sim Advanced or NX MCD. And yeah, you might wonder, Christine, how much this would cost, right?
Cost, yeah. You want to save money.
So any idea how much this would be?
Really, I have no idea. I'm not a machine builder. I have no idea how much I would have to invest here. You mentioned at the beginning that it's quite a lot of work, so I guess it's quite expensive.
Yeah, actually, the best thing about Drive Sim Basic is that it's, as a matter of fact, it's for free. So you get, you can buy the hardware, you can buy the drive, and at the same time, you can get the digital twin. So
doesn't that sound nice? Who would not want to have that for free? Isn't it? That comes as a freebie along with the real machine. That's cool. Okay. Well, selecting and dimensioning the correct drive for an application is a common challenge for OEMs. That's for sure. How can Dynamics Drive Sim Basic help tackling this challenge?
Yeah, so the current selection process actually requires a lot of technical know-how and experience. And to make this easier, you can look at the drive system behavior or the drive system model and also the application model. Drive Sim Basic enriches the application model with a realistic drive system behavior. And then based on the required functionality of the application, you can simulate the load characteristics. So that is the torque and speed curves over time. And with these load characteristics, you can then select and dimension the appropriate drive for your application, for example, in the TIA selection tool. And this way, you optimize your system design and your control patterns quite early in the design stage. And as a result, you have really well-selected Dynamics drives and Symotics motors with the help of the digital twin.
Nice. Okay. So this is one way to shorten the design phase. How about the engineering phase? Is there a way to speed up this process too?
Yeah, so there is. You can connect your drive system model to the automation model with PLC Sim Advanced. And in this way, DriveSim Basic acts as a realistic communication partner for the PLC. So you can test and optimize virtually how the drive behaves, depending on the instructions that the PLC is giving. And then it is sending back a realistic answer. And without simulation, you would need to do that on site. But with simulation, you not only save time, but you can also try out various configurations and play with it a little bit and optimize your PLC code.
Okay, sounds good. But is it possible to kind of connect all three simulation models together so you could describe to interact with each other?
Mm-hmm. Yes, if you like, you can combine all three, and that would help you to ensure that the drive behaves according to the machine performance that you desire. You can test certain fault scenarios. You can optimize all the interactions between the drive, the PLC, and the mechanical application virtually, so that overall you avoid unplanned machine behavior and increase the performance of your setup.
Mm-hmm. Do you have an example for that?
Yes, sure. So I have to switch to the next slide and make sure that the videos are running. Right, so on the left, you see a intralogistics application. It's the dynamic depot model. We've actually seen it today live when we switched to the Logimat. So
Logimat, the fair in Stuttgart.
Mm-hmm. Right. So, you have two in-feed conveyors, and there are parcels on there in various sizes, and they're supposed to be there in a certain distance. And then they're supposed to be combined on one outfeed conveyor with a defined distance. The size we can calculate with the sensor and the motor data, while the distance we can calculate with the dynamic changes of the conveyor belt. And the goal, of course, is to keep the distances between the parcels according to the requirements, while maximizing the throughput. So with simulation, we were able to reach this goal. And regarding drive systems, we were able to do three things. So first, we were able to write and optimize the PLC code in interaction with the drive. And secondly, we were able to optimize the movements of the conveyor and of the parcels by adjusting the speed controller of the drive and also respecting the feedback of the sensors. And thirdly, of course, we selected and dimensioned the appropriate drives for this application with Dynamics DriveSim Basic. So overall, we optimized the drive behavior for a maximized throughput while keeping the hardware investments really at a minimum. So you see that, to sum it up, simulation is really a great tool in your engineering toolbox to achieve an outcome fast and cost efficient and also in high quality. So I encourage you to download DriveSim Basic for free, test it, play around with it a little bit, and then I'm happy to answer your questions later today or at the booth tomorrow, of course. And you can find me
right in the center, just straight across here, really nearby. Just turn around and you're there where Veronica and her colleagues are hanging out, I'd say, in order to bring you on track in regards of simulation. Thank you so much. It really seems like that your tool is like the most precious one in the box for engineers. So I'm really looking forward to hearing more what kind of simulation processes have been developed. Thank you so much, Veronica. Big hand of applause to you. All the best, and have a great further time at the fair booth.
Thank you.
Thank
Bye-bye.
you.